Fast. All of you. What is the answer? What is the answer? Nobody.
Sir, 1 minute, sir. I'm doing.
Sir, I got, sir.
What is it?
15/2 km/h.
15/2. Harshit, Ranveer, Mokshit, Ritvik, Taufik, Shashank. Everyone should tell me. We have this done. I think 5.
Sir, I also got 15/2 km per hour.
15/2. I think we did some 5-6 questions of this type.
Sir, 15/2 km/h.
15/2.
15/2, sir. 15/2, sir.
15/2. What is this actually? We want average speed. We want average speed. Okay. The body is covering 4 km with speed 3 km/h, and the next 4 km with speed 5 km/h. Then what is the average speed? What is the formula for average speed? Total distance by total time. Total distance by total time. But if the distance is covered in 2 equal halves with 2 different speeds, then I told you to remember one formula, this one. What is it? 2 into 3 into 5 by 3 plus 5. 6 5 is 30 divided by 8. 4 is 15. So my answer is 15/4 km/h. Right or wrong?
Right, sir.
And this was this was yesterday's JEE question. JEE exams are going on now. For students who are in class 12, JEE examinations are going on from January 24th to February 2nd. They are having examinations. And this question was given in yesterday's paper, 30th January, yesterday.
Sir, this question, sir.
Exactly this question. Correct answer is
15.
option. Those who told option 1, you have lost 1 mark, negative 1 mark, minus 1 mark for wrong answer, plus 4 marks for correct answer.
Sir, in JE exam, sir.
Yes. You have negative marking in JE examination. For every wrong answer, 1 mark will be deducted. For every right answer, you'll get 4 marks.
Not attempted, sir.
0.
Okay.
That means by doing this question wrong, which we have discussed in detail, and which of the models of this question, we have done a lot of questions. By doing this question wrong, you have lost how many marks?
1 mark.
No, 5 marks. How?
Sir, we lost the plus 4 mark and 1 mark, sir.
Not technically, logically thinking. This is a very simple. You cannot get a question easier than this in JEE.
We lost 1 mark and we got lost the scope of 4 marks.
So you lost an opportunity to score 4 marks, which was a very easy question. And by doing it wrong, you lost 1 more mark for negative marking. You lost 5 marks. Logically, you lost 5 marks, but technically you lost only 1 mark. Okay. What is the point here? No, none of you remember this formula, right? No. Though without remembering formulas, how can you expect to solve questions? I think I told you this thing, not once, twice, thrice, more than once. C, D, F. These are the primary things. What is C? C is concept. D is definition. F is formula. So you should know the each and every concept that you come across in maths, physics, chemistry, biology, whatever. And whatever definitions, the terms that you get in that concept, like average speed, average velocity, displacement, distance, acceleration, retardation, whatever term you get, you should remember and understand its definition. Then you should remember the formulas that you come across in that particular concept. Then you can solve these questions. CDF is the basic. Yes.
Sir, if we know the time, if in the question the time is also given, then also we can use this formula, sir. Average speed 2v1.
You cannot use. We have discussed the 2-3 models of this thing. You go back to that class again, rewind it. When distance is divided into parts, or when time is divided into parts, how to apply the formula for average speed, what are the standard formulas that you get. We discussed that. You go back there and see this.
Sir, for how many marks, sir, exam will be?
We will discuss those details later. Now let us start the class. The JEE examination will be for 300 marks. It will be for 300 marks. Maths 100, physics 100, chemistry 100. Okay, so today we will see motion curves or graphs. Graphs. First of all, what is a graph? Have you seen a graph anywhere?
Yes, sir.
Where? Other than your classroom?
Or in stocks.
Stock exchange. The prices of the stocks will be shown in the form of a graph. And further,
Sir, information about Indian like departments, different departments.
population can be shown in the form of a graph.
Sir, the increase or decrease of sales of a particular company.
Okay, sales
Sir, sir, probabilities and forums
probability. Okay.
and world forums, Indian forums.
Okay. Then, if you watch a cricket match, then you can see the
Odds and winning odds.
the balls, number of overs bowled and number of runs scored. It will be shown in the form of a graph.
Yes, sir, after the innings.
Sir, almost everything is a graph in statistics.
So graph is actually a representation of data in a proper form. There are different methods to represent data that we have. One form is by drawing a graph. Like suppose you have a graph like this. What is this? Years and let us say what is this? Let us say average number of runs scored in each year, 93, 94, 95. Average number of runs scored, 100, 110, 120. It is like that. Okay. So by looking at this graph, you can understand that some value, this is some value which you take on x-axis, this is some value which you take on y-axis. And this graph, it shows you how y varies with respect to x, or how one quantity varies with respect to the other quantity. Okay, that is what is shown in the form of a graph. So, one minute. So graph is, it actually is a pictorial representation. Pictorial representation of a given data. Pictorial representation of given data is a graph. The different types of graphs are there. Bar graphs are there. Pie graphs are there. We don't want those details now. So I want you to understand that if you are drawing a graph, you take some quantity on y-axis and some quantity on x-axis. And that graph, the shape of that graph will show you how one quantity changes with respect to the other quantity. Suppose if the graph is like this, you have to understand that y is increasing with respect to x. If value of x increases, value of y also increases. Or if the graph is, let's say, like this, that means y is constant. Even if x changes, y does not change. If the graph is like this, x is constant. If y changes, x does not change. If the graph is like this, if x increases, y decreases. You get information like this from a graph. Now,
Sir,
yes,
sir, can graph also be z-axis also?
you can have three-dimensional graphs also. Okay, so it is a pictorial representation of given data. Given data, right? And you might have drawn graphs in mathematics. You take a graph sheet,
Yes,
then
sir.
the quantities which you want to plot on the graph, you draw x and y axis. Point of intersection is the origin, and you take a appropriate scale on x and y axis. Scale does not mean your plastic scale or your steel scale with which you draw. That's not the scale here. You assign some value to each block or each unit on the graph. Let us say 1 unit is equal to 5 centimeter or 1 unit is equal
In
to
maps, it will be, sir, political maps.
into Newton. You allot some value to each unit on the graph, and you plot the points, connect the points, you will get the graph. That's the procedure to draw a graph. You will do that in your mathematics classes. Now, here we are not going to draw any graphs. We have to understand and analyze the given graphs. You have to understand and analyze the given graphs. Suppose if a graph is given to you, you should understand how one quantity is changing with respect to other quantity. Is it remaining constant? Is it increasing? Is it decreasing? What is the variation between the quantities? You should understand these things from the given graphs. And to extract information from any graph, we use two, what you can say, two techniques. One is finding slope of the graph. Finding slope of the graph. What do you mean by this slope? Slope is, suppose we have a graph like this. Some quantity is on x-axis, some quantity is on y-axis, and the graph is like this, a straight line. Okay. Then the slope of this line means, mathematically it is the difference of y coordinates to difference of x coordinates. What do you mean by the difference of y coordinates is y2 minus y1. Difference of x coordinates is x2 minus x1. What is x1? What is x2? What is y1? What is y2? See, procedure to find slope of a graph is the given graph, any graph that for which you want to find the slope. You take any 2 points on the graph. Any 2 points on the graph. Here, graph does not mean this entire thing. Graph means this thing that you are drawing. Is a straight line or a curve, something, some shape that you get. This is the graph. So on the given graph, you take 2 points anywhere that you wish. Let us say I am taking 1 point here and another point here. And from these 2 points, you draw perpendiculars onto x and y axis. Perpendicular onto x axis. Where this perpendicular intersects or cuts the x axis, name it as x1. And perpendicular from second point onto x axis. This is x2. Perpendicular from first point to y axis, y1. Perpendicular from second point to y axis, y2. From this, you will get values of x1, x2, y1, y2. Put them here in y2 minus y1 by x2 minus x1. You will get slope of the graph. One method to find slope. Another method. Suppose if a graph is given and this angle is given, some theta. Angle made by the graph with x-axis is given. Then we can write slope also as tan theta. Slope can also be written as tan
theta of inclination, sir.
How is this tan theta? What is tan theta geometrically? It is the ratio of opposite side to adjacent side. Opposite side is nothing but delta y, which is y2 minus y1. Or adjacent side is nothing but delta x, x2 minus x1. So if you're writing tan theta means indirectly you are writing the same thing, delta y by delta x. Instead of using the coordinates x1, y1, x2, y2, you are using the angle. So we can find graph of a, slope of a given graph in these two ways. Delta y by delta x or tan theta. One thing. Okay. And or if you take the general meaning of slope. Slope means inclination, right? So slope means inclination. You have this ramp which is used to climb the vehicles into our house. So greater the slope of the ramp, greater the difficulty it is to climb over it. That's what you mean by slope in general, regular usage. The same thing means here also. So greater the inclination of the graph with x-axis, greater is its slope, right? And slope of a graph, see, we can have different shapes of graph. If a graph is like this, another graph is like this, another graph is like this, another graph is like this. So if the shape of the graph or if the alignment of the straight line is like this, then for this graph, slope is positive. Slope is positive. If the straight line is like this, then slope is negative. If it is horizontal, slope is 0. If it is vertical, slope is infinite. So by looking at the alignment or orientation of the straight line, you must be able to identify whether its slope is positive, negative, 0 or infinite. Or by looking at the value of the slope, positive, negative, 0 or infinite, you should understand how that straight line will be. This is like climbing up. Climbing up. This is like climbing down. So if the line is like climbing up, its slope is positive. If it's like climbing down, its slope is negative. Horizontal slope 0. Okay, this is about slope. Next, second technique which we use to extract information from graphs is, and remember one thing, one very important point. Whenever you are calculating slope, you are dividing the quantity on y-axis by quantity on x-axis. This is the point that you should know. All this is mathematics. All this is mathematics. From this mathematics, the thing that we are going to use in physics is, while finding slope, we divide y with x. This is the point. So you will be dividing y with x while finding slope. Or if you divide y with x, you will get slope. Y with x means in place of y, you can have velocity, you can have displacement, you can have acceleration. Some physical quantity can be there. In place of x, you can have time, you can have displacement, you can have velocity. Some other physical quantity will be there. So whatever quantity that is on y-axis, that is being divided by the quantity which is on x-axis if you are finding slope. Okay. Second technique. Area under the graph. Area under the graph. What is this? Simple. Suppose we have a graph like this again. To understand easily, this is the graph.
Sir, once can you scroll down?
Now area under the graph means,
Sir?
it is the area enclosed between.
Sir, I have a doubt.
Listen to this. Let me complete this.
Okay, sir.
If the area, it is the area enclosed between the graph and x-axis. Area under the graph means area enclosed between the graph and x-axis. What is that here? This is it. This thing. This is area under the graph. Suppose you have a graph like this. A graph is like this. Then what is area enclosed? This thing. If the graph is like this, the graph is like this. Area enclosed is this. If the graph is like this, then what is the area enclosed? This and this and this. If the graph is like this, what is the area enclosed? This and this. So how to, that is what you mean by area enclosed. How do you calculate this? We calculate area enclosed or area under the graph by using a formula of some geometric shape. Like here I can use triangle, area of a triangle. Here this is a trapezium. This is a triangle. This
So
is
next one is 3 rectangles.
this can be a square or a rectangle. This is a triangle. Like that, by applying the formulas of area of triangle or square or rectangle or trapezium, you can calculate its value numerically. Okay. And the point is, wherever or whenever you are finding area under the graph, what you actually do, what you mathematically do is, while finding area under graph, we multiply y with x. Because area of a triangle, what is the formula? Half into base into height. This is the base. This is the height. So you are multiplying x with y, basically. If you take area of a square, side into side, this is x, this is y. You are doing x into y. Even if it is rectangle, length into breadth. This is length, this is breadth. So again x into y. Trapezium, half into a plus b into h. Again x thing multiplied by y thing. So wherever you, if you find if you are calculating area, mathematically you are doing this thing. You are multiplying the quantity which is on y-axis with the quantity which is on x-axis. If you are finding slope, you are dividing the quantity on the quantity that is on y-axis with the quantity on x-axis. Very important point. We are going to use this. Remember, slope division, area multiplication, division of what? Y with x, multiplication of what? Y with x. This is what we mean by a graph, and what techniques we use to extract information from a given graph. Only two techniques are there: slope or graph or area. So for a given graph, if you get any question based on graphs, 70 to 80% of the questions based on graphs will be involved with this finding slope or area. And you should understand which to be found out in which situation, whether you should find slope or whether you should find area. You should find slope where you get division in the formula. And you should find area where you get multiplication in the formula. You will see those examples, you will understand it then. But remember this point now. Next. Some standard shapes of graphs. some standard shapes of graphs. In order to plot any graph, you need data, values of x and values of y, and there will be definitely some relation between x and y. If there is no relation between x and y, you cannot plot a graph, right? Suppose if I ask you to plot a graph between population of India year-wise and number of runs scored in World Cup. Is there any relation between these two? No relation. Population of India is in no way related to runs scored in World Cup. So that is meaningless. If you can draw a graph between number of overs bowled in the World Cup to number of runs scored, or you can draw a graph between population of India and per capita income, something like that. Okay, so there will be, the two quantities will be related to each other, and the shape of the graph will be decided by the relation between these two quantities. Each mathematical relation gives us a different shape. For example, if you have a relation between x and y, like y is directly proportional to x, or I will take, let us say, y is equal to some constant k into x. That means, how is the relation between x and y? They're directly proportional. If x increases, y increases. If x decreases, y decreases. Then the shape of this graph, if you draw a graph between x and y, the shape of that graph will be a straight line. Okay. Next, if the relation between x and y is like this, y is equal to kx square. That means y is proportional to x square. Then the shape of this graph will be like this. We call this a parabola. Y equal to kx square graph will be a parabola. Curve, not a straight line. Then suppose we have y is equal to k by x. That means, how is the relation? Y is inversely proportional to x. That means if x increases, y decreases. If x decreases, y increases. Then this graph will be, the shape of this graph will be like this. We call this as hyperbola.
Sir, these are all conic sections, no, sir?
You will study all these things in your, I think, coordinate geometry or some part of maths.
Yes, sir. We discussed in maths.
Sir, it's not only half.
You have parabola, hyperbola, ellipse, circle,
Yes, sir.
cone. You study all these shapes. And each shape can be expressed by a mathematical equation, like the equation for a straight line. What is the equation for a straight line? Y equal to mx plus c. What is m?
Sir, slope.
Slope of the line. What is c? Y-intercept. X is x coordinate, y is y coordinate. If slope is positive, how will be the line? Like this. If slope is negative, how will be the line? Like this. If slope is 0, how will be the line? Like this.
Slope infinite means it will be parallel, sir.
It will be a straight line, vertical line. Okay, these are the standard shapes, and sometimes you get this relation also. Y equal to e power x. Y equal to e power x. E, you call it as Euler's Euler's constant. Its value is some 2.71, I think. The shape of this graph, y equal to e power x, will be like this. Difference between this parabola and this is this will have more slope. This is more steeper than a parabola. y equal to e power x. Right. These are the standard shapes that you should remember. So looking at the equation, you should identify the graph. Or be looking at the shape of the graph, you identify the relation between x and y.
Sir, what is the name of the fourth graph, sir?
There is no name for this. It is just a exponentially increasing function.
Okay, sir.
Exponentially increasing function. Okay, all this was mathematics. There was no physics in this. Right from the definition of graph, slope, area under the graph, how which equation represents what shape of graph, all this is mathematics. Now coming to physics, we can represent the motion of a body, not only motion, we can represent different physical quantities, relation between different physical quantities graphically. And graphs give us an advantage that we can easily understand the relation between the two quantities. If you draw a graph between them, like if I give you a graph between displacement and time, then by looking at that graph, you should be able to identify what is the state of motion of the body. Or if I give you a velocity time graph, you should understand how the body is moving. Acceleration time graph, you should understand what is the state of motion of the body. So here, we basically get three types of graphs: displacement time, then in short, we represent it with ST. S for displacement, T for time. Second graph is velocity time graph, VT graph. Third one is acceleration time graph. Acceleration time graph, AT graph. So time is common in all the graphs. How displacement changes with time, how velocity changes with time, and how acceleration changes with time. We have to study these three types of graphs in detail, and how we can use the concepts of slope and area under the graph to calculate our required physical quantities. Like you can find out velocity from a graph, you can find out displacement from a graph, you can find out acceleration from a graph. How can we find that? That we should discuss in detail. We will do that tomorrow. Time is over. Okay, so we'll continue tomorrow.
Thank you, sir. Bye, sir. Good night, sir.
Thank you, sir. Bye, sir. Good night, sir.
Bye, sir. Thank you, sir. Good night, sir.
Thank you, sir. Bye, sir. Good night.